Okay, so today we're covering discrete versus continuous. The first thing we're going to do is define discrete in reference to math. Okay, so with discrete graphs are a collection of ordered pairs that don't allow for you to fractionalize the input values. Okay, fractionalize is just fraction, ALIZE. Now, what does fractionalize mean? Fractionalize just means that you are not able to split apart the input data. Or in other words, you can't have a portion of something. For example, like if I was talking about cars, I can't fractionalize a car. I can't say, I'm going to give you half a car. Okay. Now, obviously you could give parts of cars, but you're not going to say, here is half a car. Okay. Or you're not going to say, here's half of a poster. Okay. You're not going to cut it in half and say, oh, I can have half of the poster. So fractionalize just means that we're not able to split it up. Okay. With discrete graphs, a pattern can be established. Again. To create additional points however, this does not work if there's not a clear pattern. So a pattern can be established to create additional points. However, this will not work if there is not a clear pattern. So we're going to write down an example where it talks about how I could have discrete data, but not necessarily having a pattern, okay? Because you could have discrete data that follows a pattern, and you could have discrete data that does not follow a pattern. So for example, a scientist collects data comparing the number of days passed to the amount of rain collected. Okay, a scientist collects data. Okay. Comparing the number of days passed to the number or to the amount of rain collected. So let's make a table. So this is the table that's provided. So number of days passed is going to be our independent value. And what would be our dependent value? Yep, the amount of water or amount of rain collected. And we'll say they're collecting it as milliliters. All right, so the data that they collected is as follows. I'm just going to write it in, and then we'll discuss it here in a second. Give it a second longer to write that in. All right, so looking at this data, the couple of reasons why we know this is discrete, okay? So with discrete data, we can't fractionalize the input. So if he is counting, or she or they, the scientist is counting by the number of days passed, they're referring to whole days, okay? So they're not collecting the data every minute, every hour, they're collecting it by the day. So that day itself can't be fractionalized if they're counting all the rain from midnight to midnight, right? From 12 to 12. So if they're looking at that, we can't fractionalize that. What we also can't see is a pattern, okay? Because obviously rain is not really consistent in that regard, okay? So after 2 days and 3 days, we see that they have the same amount of rain. So therefore there's not really a pattern, meaning I wouldn't be able to predict or create any additional points. I can't say, saying 6 days passed, that it'll guaranteed be a certain number, okay? So therefore, in this example, I can see why there's not a pattern forming, as well as why it would be discrete data, because I can't find data in between each point, and I can't find data past these points. Okay, does that make sense? All right, let's talk about continuous. Okay, so continuous, the given data points create a pattern that allows you to predict values not explicitly referenced in between the given values. So with continuous information or data, the given data points will create a pattern that allow you to predict the values not explicitly referenced in between the given values. Okay, so again, discrete, we can't fractionalize, so we can't find the data in between. Continuous, we can find data in between what we're given. So let's look at an example that highlights this information. So for example, another scientist. A scientist collects data comparing the relationship between the amount of water the amount of time, I apologize, the amount of time, I read the next line, the amount of time someone presses a water button and the amount, sorry, thanks, the amount of water in the cup. Thanks, guys. Okay. So write that down, and then we're going to write down the data that represents that table. Yeah, no, Wyatt. Time is the last name. Yeah. Okay, so in this example, what would be the independent value? Yep. Good. Okay. And so like when we're thinking like a water button, we're thinking like, you know, like on a refrigerator or like a water fountain, like where you push like the bottle against the sensor or like you push the lever, like a water button in that regard. Okay. So good. So length of time. The button is pressed. Okay, and we'll say that's in seconds because that makes sense. What would be dependent on the length of time that the button is pressed in this scenario? Yeah.
The amount of water in the cup.
Good. All right, I'm going to write in the data and then we'll talk about it here in a second. right, so what I want you to do, and a couple people are still writing in the data. What I want you to do is talk to someone near you about why this would be continuous and if there's a pattern that I could find other data with. So take a second and talk to someone near you about that. All right, so what did we find? Why do we think this could be considered continuous versus discrete? Yep, it has a pattern, okay, but not necessarily, it doesn't have to necessarily have a pattern for it to be continuous, but that is the right, it does have a pattern, that is true, okay? So it does seem like for every second, you're getting another 20 milliliters of water, okay? Why would it be continuous though? Just because it has a pattern doesn't mean it's continuous. You could have a pattern with discrete data. Yep. Why is it continuous? Yep. So to clarify, I could have a discrete pattern. Okay, just because it's discrete doesn't mean it doesn't have a pattern. I just want to clarify that. Okay, why can I tell this is continuous? What's the difference? Yep. I could predict what happens next. Could I also predict what happens in between what I have? Hence the phrase in between the data. Can I predict what happens between 1 second and 2 seconds? So could I say 1.5 seconds? I would be able to predict how much there is. Yeah, so could I fractionalize this data and find like half of the data? Yeah, so that's the biggest difference between discrete and continuous. Discrete, I can't find halfway between the data, okay? It just is what the data is. Continuous, I can see that because there's that pattern, that there's data in between the points of information, okay? So in the sense of like, I could say, I could push the button for 1.3 seconds and find data, okay? It's not that I only can push 1 second and I can only push 2 seconds. Does that make sense? Right, so good. Anyone else have anything else they wanted to add to that? All right, so what I would say before we leave this page real quick is to write yourself some notes for continuous versus discrete. Okay, so remember with discrete, okay, we can't have half of the data. We can't have half of a car, half of a whatever. That's what that fractionalize means. Okay, there's no in between points. You can't have half of an input, that type of information. Okay, for continuous, I could have half of an endpoint. I could do 1.3 seconds. Okay, I also could accurately predict the future. Okay, because there's such a strong pattern, I could predict what happens next. Okay, so those are some of the differences between discrete and continuous. Okay, and the reason why I'm having you do this is because as you go on in math, regardless if it's at Sumner or whatever, okay, professors or whoever will start to write less and less, maybe talk more and write less. So you need to be able to write those things that you hear and say, oh, hey, that would be helpful for me for later. Because that's what notes are for. Notes are to help you later when you're by yourself and when you're doing things so that you can look back and say, oh, hey, this is what we were doing. That's why I did that. Not just blindly copying whatever I write, okay? So we got to practice on writing some of those things in without being told to, okay? All right, so now that we've kind of talked about what the data might look like with T-charts or table of values, let's talk about what happens when we graph this information, okay? I'm gonna give you about 30 more seconds to write what you need to write, and then we're gonna switch over to talking about graphing. So when graphing, the potential ordered pairs solutions you will need to determine if the situation is continuous or discrete. So when you're graphing those ordered pairs, you're going to have to determine if what you're looking at is continuous or discrete. And we're going to talk about the two different situations and what we would see. So if it is discrete, you graph the points that you can. And that is either just the points given. Oops, sorry, combine two words. Let's try that again. Just the given. Or show the ongoing pattern. So if it's discrete, you're going to graph the points that you can, and that's either just what you're given or show the ongoing pattern. Again, just because it's discrete does not mean it isn't a pattern. Okay, you could have a pattern. It's more commonly that you might not have a pattern. Okay, now if I'm looking at discrete data, which we talked about the definition, meaning that you cannot fractionalize the input values. If I'm plotting those points, right? If I'm plotting 4 or 5 points, would I connect the points of a discrete graph? What does it mean when you connect points on a graph? Yeah. Never mind. Anyone? What does it mean when you connect the points of a graph? Okay, so let's talk about that. Okay, so when you connect the points of a graph, what you're saying is that there is information in between the points that also works. Okay, is there points or information in between the points of discrete data? No, so therefore you do not connect the points. Okay, you do not connect the points. Because there's not data in between my points, then therefore I would not connect my data with those points. If it is continuous, you graph the points you can. And then connect them to show all of the potential solutions in the situation. So just again, to reiterate, you do connect the points. Okay, and then the last thing you do for continuous, which is different from discrete, is that you want to determine if it has a specific endpoint or continues on. How do we show on a graph if a pattern continues on? How do you show on a graph if the pattern continues on? Good. Yep, you draw an arrow in the end. Okay, arrows in math mean that the pattern would continue. All right, so last thing we're going to do before you have your time for yourself, the homework, we're going to show two different examples for each to show the difference between continuous and discrete. Okay. I'm going to give everyone a little bit more time to write that, and then we'll talk about those examples. Okay, so let's talk about a difference between a continuous and discrete graph. Now, I don't want you to think that these two different types of data points or data situations have to be completely different, because they don't. Okay, so we're going to describe a situation that is very similar, but one is continuous and one is discrete. Okay? But we're going to start off with the second example that we wrote, which was the scientist that collects data comparing the relationship between the amount of time someone presses a water button and the amount of water in a cup. Okay, so we're going to stem off that situation. So for this situation, we're still going to be talking about the amount of water, which was our dependent variable. Okay, and dependent, what's another way of describing dependent? What variable on a chart would that be? The y. And what axis is the y-axis on a chart? The vertical one. So we would label the amount of water on my axes. How we're going to make this different is the independent value. Okay. So on this one on the right here, we're going to say that this is going to be the seconds of pouring water. Seconds of pouring water. Now, if I am pouring water, and let's say it's a really big jar or something, okay, would that data be continuous or discrete? Discrete, continuous, let's think about it. So since we're stemming off the example that we did here, okay, where they're pouring water into a cup, was this continuous or discrete? This was continuous, okay? So if we're thinking about this of seconds of pouring water, okay, could I find half of a second? Yeah, so if I can find half of a second or a second and a half, is that continuous or discrete? Continuous, okay? Remember, it's based on what you're looking for. So if I'm doing seconds, time can always be continuous, right? Time doesn't stop in the real world, okay? So therefore, the amount of water and the seconds of pouring the water is going to have a continuous pattern. However, if I thought about the situation slightly differently, how about what if I was purchasing a number of bottles of water? Still getting water, but I'm getting them in bottles. Okay, would bottles be continuous or discrete? Discrete, right? I'm not going to buy half a bottle of water, right? Exactly. I don't sell it. That would be kind of unethical and unsanitary. Okay, so therefore my amount of water in my bottles is going to be discrete. So if I buy one bottle, I'll have so much water. If I have 2 bottles, 3 bottles, so 4 bottles, 5 bottles. So as you can tell, there's still a pattern aligning here, but I can't say it's continuous because I can't say, oh, I bought half a bottle of water. I bought 3.3 bottles of water. Okay, so it's a similar situation where we're talking about water and how you're gaining that water. Okay, but because we're referring to seconds of pouring versus like number of bottles, we have different types of data going on. Okay, does that make sense how that similar situation has 2 different types of data? Yes, no, thank you for sign of life. Okay. All right, so I'm going to show you 2 different examples and it's going to be on a PowerPoint screen. So give me a second while I switch that over. All right, so this is the example we worked with on the last set of notes, okay, about Joan and riding her jets because she likes her rock and roll, okay? Now, when we talked about that, we came up with a function rule that looks similar to this. We used x instead of e, but similar concept, right? So it was negative 4x plus 200, or in this case, negative 4e plus 200. Okay, remember how I said you could do different variables if you wanted, but typically we stick with x, and that's okay. So in this situation, would this be continuous or discrete data? Why would you say discrete? Because it can change. Because there can't be half a seat. That's the kicker, okay? When you're thinking about discrete and continuous, that biggest thing you want to think about is, can I fractionalize the data? Can I have half of whatever I'm putting into the scenario? In this case was number of empty seats, right? So can I have 2.5 empty seats? No. Yes, but in reality, we would not. Remember, we discussed that. Okay, so if we're looking at the data, it's going to be lots of little points of data. Okay, I can't say this is continuous data because I can't say that there is a fractionalized version of a seat. Okay, does that make sense why this would be discrete? Okay, different example. Oh, sorry, I didn't talk about this. As you can tell, we have some labels on this. Okay, you will also do this on your assignment. You have to label the axes like we were doing just now. Okay, number of empty seats, cost of ticket, and there's also a title. Okay, a title of a graph is really just a summary of what you're talking about. Okay, and obviously numbers. Okay. The second example, now I forgot how many clicks I had. Okay, is find the area of a square garden. You square the side of the square the side length of the garden. Got that out. Sorry. And we talked about this example a couple of times as well. Okay, so if we were to square the length of garden, that means we're going to take that and square it, right? X2 squared, 4 squared, 3 squared, whatever we were doing, okay? Would this be continuous or discrete? Continuous. Could I find 2.5 as a side length and square it? Yes. So therefore, this situation would be continuous, and this would be an example of a graph, okay? So we think the length of the garden side, I could have a length that's 1.2. It doesn't have to be exact measurements for my side length, correct? So therefore, I could still square it, and it would keep going and going and going, right? Continuous. Make sense? Okay. So the biggest things you want to think about is the type of data. Can I fractionalize it? Can I not? Okay. Don't really think about pattern versus not pattern. Think about, can I fractionalize the data? Can I not? Can I find data between the points, or can I only find the points of information? Okay. So those are just a couple examples so you could see a few more or a couple more examples, but let me show you your homework and what's going to be expected of you on your homework. Okay. All right, so on your assignment, you only have 4 problems. Now, with the 4 problems, you do have a handful of things to do. Not to say it's going to take you very long, but you do have things. So, looking at example number 1, in bold up here, eyes up here, heads up, please. This is your instructions, okay? Please follow them. So, first thing you're going to do is create, well, after reading the problem, you're going to create a table of at least 5 inputs that make sense for the situation. Now, we've discussed that in the last lesson. How do we know if something makes sense? Do we have negatives? Do we have positives? Could I have half of something? Is there appropriate range of information? Okay, so you're going to pick 5 values, meaning not every single person in here should have the exact same 5 values. Okay. Once you do that, you're going to find your corresponding outputs, meaning you're going to substitute your inputs like you did on the last lesson, find your output, and you're going to graph those ordered pairs. Okay. You only have to do at least 5. Then you're going to label your axes. Remember, our x-axis is going to be your independent variable. Your y-axis is going to be your dependent variable. You're going to title the graph, so summary of what's happening. And then you're going to also list numbers on both axes. Okay, so if you're plotting points, you have to have numbers, right? That makes sense. Okay. And then if you are plotting your numbers, make sure that you're not jumping. So don't go like 1, 3, 7, 10. Like you have to do continuous numbers. So like 1, 2, 3, 4, 5. Or you could say 2, 4, 5, not 2, 4, 5, sorry, 2, 4, 6, 8, or so forth. Okay. Last thing you're going to determine is if it is continuous or discrete, and you're going to state why. Okay. So you're going to say, oh, this should be continuous, this should be discrete, and explanation why. Okay. Your explanation should not just be, I can have half an input, I could not. It has to apply to the scenario. Okay, so I could have half of this, or I could not have half of this. This is continuous because of this reason. This is discrete because of this reason. Okay, it should not be the same reason in every problem. Okay, so you're going to do that 4 times, and that's your homework. Okay, so not to say that's a long process, but obviously you are creating a little bit more than you have in the past. Okay, any questions or concerns regarding the assignment? Okay. So homework time for you.